Hey everyone. So what we're going to talk about today is congruent triangles and how we can determine whether two triangles are congruent when we are given specific pieces of information. So first thing we want to do is remember that the definition of congruent is that they are the same size and same shape, and the definition for congruent is the equal sign with the tilde over it. The definition of congruent triangles, of course, is the same size and same shape, as we said. And what that means is that all corresponding parts, that would be sides and angles, are congruent. So every angle is congruent, every side is congruent. When we say triangles are congruent, we write a congruency statement, and a valid congruency statement must match all corresponding angles and sides. So what that means, and I want you on your copy to use the highlighter to demonstrate this. And it's going to be a couple different colors. I'm going to use the freehand highlighter because that lets me make dots. So we have triangle ABC is congruent to triangle DEF. So that means angle A and angle D, because they both come first, they are congruent. So you see how it has one arc mark, one arc mark. That also means that angle B and angle E are congruent. Two arc marks, two arc marks. And that angle C and angle F are congruent. Again, three arc marks and three arc marks. That also tells us, again, that the corresponding parts are congruent. So AB, we have our blue to red. AB, blue to red, DE. You can see in the congruent statement that they are also next to each other. So see A, B, blue to red. And again, we have BC, BC. And so we see that's two tick marks. It's going to be congruent to FE. Again, we have them next to each other in the congruency statement. And then finally, the last one's a little more difficult to illustrate, but let's go ahead and give it a try. We have AC. We got the first one and the last one. And the first one and the last one together make up the third corresponding part. So I do want you to color code. You do not necessarily need to color code the same as I do. All right. So we have a common expression in determining congruent triangles. We have a phrase that's called CPCTC. Now, I'm not going to lie to you. I actually have an easier time saying corresponding parts of congruent triangles are congruent. I do not know why I actually have such a difficult time saying CPCTC if it's not right in front of me, but corresponding parts of congruent triangles are congruent. So if we know that two triangles are congruent, then we know that every pair of corresponding parts is also congruent, just like I illustrated in this image here. So we have here, it says triangle JKL is congruent to triangle PQR. So again, just like I did up here, I could do it from the congruency statement. So see, first letter and first letter are congruent for angle. So let's do that again with our highlighting tool. And you should probably, it doesn't matter what colors you use. So again, I'm going to say first letter and first letter. So that means that angle J is congruent to angle P. I then also know K and Q. All right, guys, so you'll notice that this is suddenly filled in. Unfortunately, I discovered that my microphone was turned off. So I must have bumped the mute button or whatever. So now I'm going to go ahead and just tell you what I did in the meantime. So I have angle Q and angle K are both the middle letters of our congruent statement. So angle K is congruent to angle Q. L and R are the last letters of our congruent statement. So angle L is congruent to angle R. We can do the same thing again with the sides. J, K are our first two letters. P, Q are our first two letters. So JK is congruent to PQ. KL are our second two letters. QR are our second two letters. So KL is congruent to QR. And finally, J is our first letter, L is our last letter, P is our first letter, R is our last letter. So JL is congruent to PR. I did the same thing over here for this triangle set. You can see where I highlighted the angles in one color and then drew the lines for you as well. Same concepts apply. So let's look at this next example where it tells us that given that triangle KMP is congruent to triangle AYC, complete each of the following statements. So the first thing we're going to do whenever we see a problem like this is put in our congruence markings. So they tell me angle K and angle A. So again, K is our first letter and A is our first letter. So we're going to mark those congruent. M is our second letter and Y is our second letter. Now, if you look at this, that is not how it looks here. All right. Well, we're going to do it the way it's said, okay? So, sorry, I got distracted for a moment. Now, I know that these angles do not look congruent, but given our congruent statement, this is what we have to say is true. So again, they told me that in the congruent statement, P and C. So even though they do not look like they are congruent, we're going to do the same thing with the lines. So KM is one segment. AY are the first two letters there. MP are our second two letters. And on here we have YC is our second two letters. And finally, KP is our first and last. AC is our first and last. And this is a perfect example of why you need to make sure you pay attention that you are doing this correctly. Okay, so let's go ahead and answer the questions. We have segment KM is congruent to which segment? Let's take a look. KM is going to be AY. So we're going to say KM is congruent to segment AY. Then we're going to look at the next one. It says segment CY. CY, those are our last two. So PM. And again, it doesn't matter if you put MP or PM. I'm just going to put them in the same order they appear in the congruent statement because that is the easier way to handle this. PK, last and first. So CA, last and first. Up next, angle Y is congruent to angle M because they are the same, both in the middle. And I know this is a little bit weird, but it's why we don't eyeball anything. Angle K is going to be congruent to angle A because they are both the first letter in their congruent statement. And then it says ACY. We can look at our picture, ACY, or we can look here, ACY. First, last, middle. First, last, middle, KPM. And then we have right here, we're going to practice writing two new triangle congruent statements. So MPK, MPK. So we're going to do the same thing in order. YCA. You can do the same thing from the image, of course. So MPK, we start at M. We go, that's two markings, to our three markings, to our one marking. 2, 3, 1. So for this one, MPK is going to be congruent to triangle. And again, for triangle, we're just going to use the delta symbol. Triangle. MPK is congruent to triangle YCA. And again, I'm just doing it from the congruent statement to be perfectly honest here. All right. YAC, so middle, first, last. Middle, M, first, K, last, P. So again, use delta for triangle, MKP. Now on the next one, we are given the same information, but we're given angle measures and line segments measures. So again, what we're going to do is we are going to do our congruence tick marks. So again, we have ST to BF TW, FN, and SW, BN. So I like SW as my shortest one over here. So SW is BN. TW is my second longest one. And that's going to be with FN. And then finally the last sides. BF are our first two letters. ST are our first two letters. And so they are congruent. Again, we also want our congruence arc marks. So we have S and B. So angle S is congruent to angle B. Angle T is congruent to angle F. And angle W is congruent to angle N. Okay. So then all we have to do is put in our measurements. So BN is congruent to SW. SW is 9 centimeters, so therefore BN is 9 centimeters. TW is congruent to FN. So FN is 14 centimeters, so TW is 14 centimeters. And finally, BF is congruent to ST. ST is 17 centimeters, so BF is also 17 centimeters. Angle W is congruent to angle N. So that means that if angle W or angle N is 82 degrees, then angle W is 82 degrees. Angle B is congruent to angle S. Angle S is 67 degrees, and so therefore angle B is 67 degrees. Now, to do angle F, we are going to need to subtract from 180 because we do not have angle T or angle F, but again, we can find that by going with 180 minus the sum of the other two angles. And remember, you can run that directly through Desmos. And we get 31 degrees. All right. So that's what we do when we know triangles are congruent, but what if we don't already know? What if we're not told? How do we determine that triangles are congruent? There are 5 ways to prove two triangles are congruent without being given all of the corresponding parts. Now, if you recall from the Desmos activity that you worked on, 4 out of 5 of those require you to have 3 corresponding parts. Actually, all of them require you to have 3 corresponding parts. However, one of them is a little bit weird because it's only 2 letters. I'll explain when we get there. But first of all, let's talk about side, side, side. The first way that we most commonly know is side, side, side. That is the easiest one to do. Side, side, side just means all 3 sides are the same. So if I have 3 triangle lengths, there's only 1 triangle I can make for it. So in this instance, if segment AB, and in this case they tell me segment AB, I'm just going to say if segment AB is congruent to segment DE. And then our next one, we want to say BC and EF. So segment BC is congruent to segment EF. And finally, segment AC and DF. Okay. And if that is a true statement, then we can say the triangles are congruent by side, side, side. And the way we write this congruent statement is, again, we need to follow the line. So if we start at A and cross over 1 tick mark to get to B, then on our second triangle, we need to start at D and go across the 1 tick mark to get to E, B to C, E to F. So triangle ABC is congruent to triangle DEF. The next way we can do this is called side angle side, SAS, and you never have to write it outside angle side. It is always acceptable to say SAS. Now, if 2 sides and the included angle, and I have given you here the definition of included in this case is the angle in between the sides of one triangle, is congruent to 2 angles and the included side of another triangle, then the 2 triangles are congruent. So again, included, it has to be between the sides. So again, E is between DE and EF. Notice they both have the same endpoint. And AB and BC, they share an endpoint. So if segment, because it says a side, so we're doing a side, segment AB is congruent to segment EF, oh, sorry, not EF, BC, and angle B is congruent to angle E, and segment BC is congruent to segment EF. Then we can say the same, the two triangles are congruent by side, angle, side. And again, it's going to be the same congruent statement as above because it's the same two triangles. So ABC is going to be congruent to triangle DEF. All right, moving right along. Our next one is called angle, side, angle. If two angles, and again, the included side, remember the side in between the angles, of one triangle is congruent to two angles and the included side of another triangle. So again, right here, we've got angles and a side between, angle and the side in between. So if you have that case, then the two triangles are congruent by angle, side, angle. So for the example triangle here, we have if angle A is congruent to angle D, like delta, and segment AB is congruent to segment DE, and angle B is congruent to angle E, then the two triangles are congruent, so it'd still be ABC is congruent to triangle DEF. And again, I just copied and pasted that so that it would be. Our next one is called angle, angle, side. Again, this is two angles and the non-included side. That is the side that is not in between the angles. In this case, it is not included. Okay. If two angles and the non-included side are congruent to two angles and the non-included side of another triangle, then the triangles are congruent by angles, angle, side. So again, here we have angle, angle, side, angle, angle, side. Now, if you did actually watch through the videos, the one with the little Chinese boys who dance through the school, that's great because it does remind you of all of the others. But it does leave one out, which we'll get to in just a moment. But this is the one they end in a. But they go side, angle, side, 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 angle, side, angle, 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 side. So again, these are the four primary ways that we do this. That green darker, that's not a good writing green. So if angle A is congruent to angle D and angle B is congruent to angle E, and side BC or segment BC is congruent to segment EF, then the two triangles again are congruent by angle, angle, side. The last one we use is called hypotenuse leg, and again, that is only applies to right triangles. Right triangles only, none others. Right triangles only. Now, this is a unique one because if you remember from the Desmos activity, angle and then two sides is not one that we can do. If you watched this video, Congruent Thoughts, he actually shows you a picture of a donkey because remember the abbreviations, we've had angle, angle, side, AAS, angle, side, angle, ASA. So just stop and think, what would angle, side, side be? That's what we want to avoid, okay? Not angle, side, side, all right? So if the hypotenuse, which again, although we haven't really talked about it much, the hypotenuse is the side across from the right angle, and a leg, a side adjacent to the right angle, of one right triangle is congruent to the hypotenuse and leg of another right triangle, then the triangles are congruent by hypotenuse, leg. Hypotenuse, leg. All right. So if, in this instance, segment BC, which in this case is our hypotenuse, is congruent to segment EF, then, and the leg is congruent as well. And of course, there are two legs, and it could be either leg. So in this instance, they gave me AB is congruent to segment DE, but it could just as easily be AC and DF. Then our two triangles are congruent. ABC is congruent to DEF by hypotenuse leg. And this is one that we use only for right triangles. The reason it works for right triangles and not any other triangle is that if we were to rotate two right triangles and put their hypotenuses together, we would get a rectangle. And in a rectangle, the sides are always going to be congruent, the opposite sides. That's why this one works. It doesn't work for any other triangle, so do not do it for any other triangle. The other reason it works is if we put these two legs against each other and it was an isosceles triangle, then angle D and angle B would be congruent, and it would be angle side angle. So it actually works out really well, two different ways. All right, so let's do a couple of practice problems. It's really not too difficult. First thing we're going to do on each of these problems is mark what extra congruence we know. So for example, number 1, we have a shared side, and remember our reflexive property says that A equals A. That applies in geometry or in our segments as well. So this is angle 1, 1, 2, 1, 1, 2, angle, included side angle. So we're just going to say if it's true, we're going to put angle, side angle. Okay. Next one, we see again they share a side. I want you to mark shared sides congruent every single time. This one has 3 congruent sides, so it is side, side, side. Number 3, we have an angle, angle, side, 2 markings, one marking, 2 markings, 1 tick mark, 1 marking, 2 markings, 1 tick mark. So this one is going to be angle, angle, side. Next one, number 4, we are given, again, we see our rectangle again. Here's our rectangle. Now, this is a rectangle, which means these are parallel. That also means this angle here and this angle down here is congruent. We know all this. It's actually just a very interesting scenario. But because it is 2 right triangles and we are given the hypotenuse and the leg, that means these are congruent by hypotenuse leg. Remember, they have to give you both the hypotenuse and the leg in order for that to be true. Number 5. Now it looks like it's only given us 2 sides, but we need to remember these are vertical angles right here, and those are congruent. However, this is angle, side, side, angle, side, side. Remember, there is no angle, side, side. It does not work. So we're going to say none here. These are not proven. Does that mean they are not congruent? No. It means we cannot prove them congruent. All right, number 6. Just as a reminder, these little arrows right here mean that these lines are parallel. So what that tells me is this angle here, if we look here, is congruent to this angle here. Okay. It also tells me that if I were to extend these lines out, then this angle and this angle are now corresponding angles and are therefore congruent. And we have angle, side, angle. So parallel lines are important to remember our relationships. Angle, side, angle. Angle, side. Now this next one, number 7, it does look like these are right triangles. However, we are not told explicitly that these are right triangles. So therefore, we cannot say this is hypotenuse leg. What we can see is that they gave us the angle in the middle of them right here. So this is going to be side angle side. All right, up next, number 8. Again, we have a shared side. Let's go ahead and mark that. And again, we have, in this instance, side, side, side. Number 9, we have right angles. We're given the long side, which is across from the right angle, and we're given one of the short sides. So therefore, these ones are congruent by hypotenuse leg. Number 10, again, we have vertical angles. We're given 2 angles and a non-included side. That's going to be angle, angle, side. All right. Number 11 does not have enough information. We can say that this shared side is congruent, but we have no way of ascertaining the length of any of the other sides or the measure of any of the other angles. So in this case, we cannot prove, so you can say none or not proven. Now, this next one looks like it's trying to trick us into the fact that this is going to be an angle side, side again. But remember, notice here, we have another set of the parallel line markings. So that tells us several things about this image. If I continue this line out, I can make claims about the angles. So this angle here and this angle up here are alternate interior angles. So now we have angle, angle, side, and that will definitely be a correct one, okay? So we have 2 angles and a non-included side. We can do either of them. This is angle, angle, side. So you have to think about what do you know from other units that could possibly help you. And that's all we have for our congruent triangles lesson. Make sure that you color code where appropriate and that you have all these answers filled in so that you can get full credit on these notes. Feel free to check out the videos that are in the notes, linked in the notes, and I will actually link those videos in the description box on YouTube as well, so that way everyone who wants to see them can see them. But that's all I have for you, and I'll see you later. Stay safe.